Okay, everybody, let's go ahead and get back started again. And we're going to move on right on to dynamometer operation and dynamometer safety. So I'll go ahead and share my screen and we'll move right into the presentation here. Let me get this up and running and up. Let me just go back a few steps here. Okay, and there we go. Okay, so as you can see here, there's a couple of different styles. There's the in-ground installation and above-ground installation. We have both to work with in our shop. And the above-ground installation is the one that sometimes gets technicians a little nervous because we're actually on an incline. Both of them are relatively the same. Um, both of these will sometimes have the cars will wander slightly if they're front wheel drive vehicles. Typically rear wheel drive vehicles, not a big problem. But again, today, many cars that we test today are of the front wheel variety. So we have to make sure that they're safe and that, you know, the tire pressure is correct, the tires are of the same size and configuration, things like that. But they're, again, they're relatively safe. This above ground installation, this kind actually is mobile. We can actually take and move it around, and we can move it from, you know, different places. So it's pretty helpful that it does not, you know, that it doesn't have to sit in one primary location. Okay. A couple of things to consider. Remember, we got to remember, like in your training says, that there should be a minimum distance of 6 inches from the center plate. That is because cars will wander left to right or laterally on this dynamometer, and this plate can actually take and rub down the tires really quickly. So you have to be careful that we get these nice and even on the dynamometer. Okay, and again, to the center plate. Okay, always want to put the front of the vehicle or the center of the vehicle right in the front, middle of the center plate, and then have the lateral. These are called lateral restraints. Okay, lateral restraints typically 2 to 4 inches from the tire, right? From the tire sidewall, 2 to 4 inches is the correct distance. And whenever we're bringing the vehicle on, we want to put them on the outer position until we take and we center the vehicle, drive it on the dynamometer, the vehicle kind of settles in, okay? Then we can move them in after we've already got the vehicle centered, okay? Try to never put these inside until after we center the vehicle, because the vehicle will move side to side until it evens out, okay? Other thing is that here it says when driving onto the dynamometer, it says use a technique. In other words, look out the side. Well, for our purposes, until you guys are actually working in a shop or something like that, for our purposes, we will always use another student or one of your team members to help you drive onto the dynamometer. Never ever attempt to drive onto the dynamometer by yourselves, okay? All right, and moving on. So here on this tile here, remember that we have the ramp style. Be very careful. Don't drive off the front of this dynamometer. Make sure that the actual lift is always up. Okay, but be very careful not to drive off of it. The vehicle will get stuck. Very difficult to get back off of there. I've seen this happen to technicians before. Okay, so again, it says when driving the ramps, if necessary, gently apply the brakes. Okay. So again, very careful. Always use an assistant to help you get up and down off the dynamometer. Okay. So here we see a vehicle, a rear-wheel drive vehicle on the dynamometer. Notice that the dynamometer is bidirectional, so it doesn't matter. It'll measure either way, forwards or backwards. Okay. Notice that the vehicle is properly restrained. Again, typically we do not put these wheel chocks on until after we've taken and we've driven the vehicle slowly on the dynamometer, so it takes and it adjusts itself, okay, or centers itself. Then we will put the actual wheel chocks on. On a rear-wheel drive vehicle, we do not apply the parking brake, okay, but we do the wheel chocks. On a front-wheel drive vehicle, we do apply the parking brake. Okay, keep that in mind. And notice that this vehicle, the weight scale, okay, is right in the center. So typically we want to take and uh, as it says here, do not drive onto the weight scales until the dynamometer prompts you to do so. Okay, and here it looks like we're driving up a front-wheel drive vehicle. This is our this is the SPX Clayton dynamometer, which is to the right of the shop. Okay, and again, here we have a rear-wheel drive vehicle. Okay, this rear-wheel drive vehicle, same dynamometer. Okay, positioning safely on the dynamometer itself. So here's just some configurations. You know, you never want to, you always want to be as straight as possible forward, just like so. Okay, never leaning left or right. The vehicle will wander left or right and can actually cause damage to the machine, to the vehicle, or it can be a dangerous situation. Okay, but all we got to do is make sure that we drive the vehicle straight onto the dynamometer, and it should be safe. It should not be a problem at all. Okay, remember the lateral restraint, 2 to 4 inches from the tire. Okay, 2 to 4 inches from the tire. I mean, as close as you can get. If 2 to 4 inches is if it's too close, you have to move it on over as close as you can get. Again, 2 to 4 inches from the sidewall of the tire. Okay. You also don't want it right up against the tire. You want to give it a little bit of room. Okay. These are the wheel chocks that we typically use. Okay. Notice that this wheel chock is not right up against the tire itself, okay? Because when we release these, we sometimes are going to have to kick these blocks, okay? We're going to have to kick these blocks. I'll show you exactly how to set these up. But remember to take and put them away from the tire, okay? So always leave yourself some room. Never snug them right next to the tire. And if you notice in this first picture, see this device? That's called the pin. Okay, that's called a pin, like a grenade. Okay, so on this pin here, when this pin moves up and down, in the up position like it is now, that's when we're going to be able to go ahead and step on this lever to take and adjust it. When we're going to release it, we put the lever down, okay, and then we kick down hard on this lever, kick down hard, and that'll usually release the blocks. That'll usually release the blocks. If they do not release though, then like I said, we're going to have to take and kick it, physically kick it to release the blocks here. If you put them right next to the tire, whoops, let me go back there. If you put them right next to the tire, there's no way you can get in there and kick the blocks. So it becomes very difficult to remove them, okay? Next, we are looking at how we can take and if we need to, we're going to take and we're going to tie down the vehicles. Most of the time, we do this only to secure the vehicles that won't stay on the lift, or I'm sorry, that will not stay on the dyno. Usually when a vehicle will not stay on the dyno, it is because it either has a tire that has some kind of separation, a tire has a defect that we can't see, or the vehicle is severely out of alignment, okay, which happens all the time. One clue is that when you drive the vehicle up onto the dyno, the steering wheel is not centered. Okay, so that's one thing you can look for. But we will practice taking and adjusting these, or I'm sorry, setting up these vehicles with the straps, okay, in case that you ever have to use these. And part of the training is that you have to take and install a vehicle with a strap. So every team will have to take and strap down the vehicle, drive it on the dynamometer, okay, and I'll show you the steps. I don't want to go through the steps here. It's easier to show you on the ground, okay, or when we actually do it in the shop, okay. We will always have a fan, okay, we'll always have a fan. We will position fans in front or near the vehicle, even though it's typically cool at Skyline. You always want to have a fan next to the vehicle. I'm not going to require you to run the fan all the time, but when we run under a load, yes, we will. Okay, if we're just measuring, if we're just practicing driving the vehicle, I'm not going to have you turn the fan on, but the fan needs to be very, very near the vehicle. Okay. So again, here we have a vehicle. We're testing it. We're doing an emissions test. Notice that that the vehicle is on the above ground dynamometer. This is a rear-wheel drive vehicle. Notice also that if the vehicle has dual exhaust, while we're going to have to take and make sure that we cover both of the sides of the exhaust, because of course we don't want that getting into the shop and getting, you know, getting gases all over the shop and us breathing that in. Okay. Okay, so this gets us to the section where we're going to talk about the test we're going to do. Okay, so this is one of the tests that we're going to do when we do engine testing. We're going to check engine vacuum. Okay, but again, that's going to come in a couple of weeks, or yeah, actually, just we're going to start doing that next week actually. Okay, so next week is engine testing. So we're going to start measuring engine vacuum. We'll use the dynamometer when we do engine vacuum and tailpipe emissions, again, during engine testing, which is next week. Pre-CAT versus post-CAT emissions, we'll do that during emissions testing, which is towards the end of the semester, actually. Okay. Then we have engine vacuum versus fuel pressure and injector pulse width. We do all of this during fuel systems testing. And ignition system testing using a scope. Again, we'll do this during the ignition system testing. Again, using the scope. And then this is the one we're gonna be doing this week. Okay, for a lab, we'll be measuring the emissions, and we'll be able to see under load. Okay, notice that here's the settings that we're gonna use. We're gonna use different settings, and we're gonna measure the load of the vehicle. I'm sorry, we're gonna measure the emissions of the vehicle as we drive in different settings. Okay. The last part of this, I'm going to go ahead and just power through it. I was going to stop and give you guys another few minutes to gather yourself. So I'm just going to power through it. This is just talks about the Bar 97 diagnostic menu. Now, since this is the older version of the analyzer, which we may or may not use, I'm not going to go totally through it, but I'm just going to click on this next few slides. What we usually do is we're going to go to manual testing. We're going to go to no load emissions testing. That carries the same for all the equipment. Okay, we're going to go to no load emissions measurement. But then we're going to actually go to technicians selected steady state. Okay, so this is under no load. You guys already did this one. Okay, but what we're going to do is we're going to go to technician selected steady state and we're going to load it. Okay, and here's where we can select different ways of loading the dyno. We can either select horsepower, we can actually select the amount of incline. Okay, and notice that this is indicating 50 miles per hour at 14.6 horsepower. Okay, and here we have again 25 miles per hour. Okay, at 14.3. And like I said, we'll go over these and I'll show you how to use the newer pieces of equipment as we get ready to do our dynamometer testing. Okay, so that wraps up our lecture, short and sweet. Go ahead and make sure that you get your testing done. I'm sorry, your quizzes done before we get ready to get together for class. Other than that, I will stop sharing my screen and I will stop this recording. So again, we'll see you this week in lab. Bye for now.